This is a question from May-June 2019, question 3. Some airbags contain silicon oxide. When the airbag is used, sodium oxide is formed. Oxides can be classified as acidic, amphoteric, basic, or neutral. So if you refer to the notes that I have uploaded, you can come across this table in your chapter acid, base, and salt. Elements can be divided into two different types of groups. They could either be metal or non-metal. If this metal reacts with oxygen or oxide, they would form basic oxide and amphoteric oxide. For amphoteric oxide, there are only two famous examples that we come across, which would be aluminium oxide or zinc oxide. These are the two example metals which form amphoteric oxide. As for elements which are non-metal, when reacts with oxide, would tend to form acidic oxide and neutral oxide. So in this question, as we can see here, sodium is a group 1 metal, so it is a metal. Now silicon is non-metal. So if metal reacts with oxide, it would form either basic oxide or amphoteric oxide. Since this is sodium, it is not aluminium or zinc, it would be basic oxide. Now the next one is silicon oxide. So silicon oxide is non-metal. It would either form acidic oxide or neutral oxide. However, silicon oxide falls into the category of acidic oxide as it can react with base. Neutral oxide would be example like water, carbon monoxide, or nitrogen oxides. So your answer for silicon oxide would be acidic oxide. Question 2. Lead azide is insoluble in water. Solid lead azide can be made in precipitation reaction between aqueous lead nitrate and aqueous sodium azide. Lead 2 azide has the formula of PbN3,2. So this means that when lead reacts with azide, it forms PbN3, that means this is N3, and there is a bracket of 2 over here. This means that this 2 belongs to the charge of Pb, which is 2 plus, and since there are no number here, this means it is 1. So it would be minus 1 over here. So they're asking you to deduce the formula of azide ion. Now azide ion would be N3 minus 1, but it's not necessary for you to write the number 1 here. So your formula would be N3 negative charge. Complete the chemical equation for the reaction between aqueous lead nitrate and aqueous sodium azide to form solid lead azide and aqueous sodium nitrate. Include the state symbols. Now when lead nitrate reacts with sodium azide, it forms lead azide. So lead and azide has reacted with each other. So your next product would be sodium and nitrate, giving you sodium nitrate. It would be NaNO3. Now your next step would be to balance it. So as you can see on the equation here, you have got 2 nitrate over here. So I'm going to put 2 here to make it a balance of 2 nitrate as well. However, putting a 2 here would give you 2 Na. So we need to balance it by putting a 2 here to give 2 Na as well. Now this gives you an azide of 2. However, there is already 2 over here for azide. This means azide is balanced, and we only have 1 lead and 1 lead here as well. So now this equation is balanced. And the final step would be to include our state symbols. Since they have already mentioned solid here for lead azide, you're going to put S over here. And they mentioned an aqueous sodium nitrate, that means AQ over here. Next question. Describe how you could obtain a sample of lead azide that is not contaminated with any soluble salts from the reaction mixture. Now this question is similar with the one that we have discussed before, whereby you need to lay out the steps to obtain a soluble salt. So if you refer to the previous question that we did, this would be the steps that you can perform in order to obtain your salt. However, since this question only gives you 2 marks, we don't need to write all 3 steps. We could just simplify it and write, filter the sample and rinse it with water. This would be sufficient enough to give you a complete 2 marks. Now question E is a calculation question, and I have already covered how to calculate empirical formula in our previous videos. This is the question from February-March 2017. Question 2 says that silver dichromate is a rate-insoluble salt. Silver dichromate can be made by reacting silver nitrate with ammonium dichromate. The chemical equation for the reaction is shown. So here it is. Question A. Describe how you could obtain pure dry solid silver dichromate, which is this one, your insoluble salt, after mixing silver nitrate solution and ammonium dichromate solution. So the first step would always be to filter it out in order for us to separate our filtrate and our residue. So over here, the one that goes through your filter funnel would be ammonium nitrate, as it is soluble and it is aqueous. The one which is solid would remain in your filter funnel after being filtered, because this one is insoluble. So the first step, so filter the solution first. After you have filtered, you would get your filtrate at the bottom and your residue. Since this residue contains silver dichromate, what you need to do is you need to wash the residue using water. After you have washed the residue or rinsed the residue, now your residue is clean and does not have any contamination. Once you have obtained a clean residue, the next thing that you need to do is dry the residue between filter paper. Once you have dried the residue between filter paper, you will be able to remove all the water components that is in your residue. This way you can get a pure, dry, solid silver dichromate. Pure because you have filtered it out, and dry because you have evaporated all the water. Now question B, the charge on silver ion is +1. Deduce the charge on the dichromate ion in silver chromate. So this would be your dichromate. As you can see here, it is between silver and chromate. There are two, there's number 2 over here, meaning that 2 belongs to the charge for chromate, giving you 2-, and there are no number here, meaning it is 1, and 1 goes here, giving you a +1, which is correct. So the charge for chromate will be -2. Write the ionic equation for the formation of silver dichromate in this reaction. So the ionic equation would be such that silver ion adding up with dichromate ion giving you this. So this would be your ionic equation. Now ionic equation means there must always be your charges present on your ions. Moving on to the last part of this question, C. Dilute aqueous sodium hydroxide was added to the ammonium nitrate solution which was made in the reaction. This one says that the mixture was then warmed and the damp universal indicator paper was held above the mixture. State and explain what would happen to the universal indicator paper. Now before we answer this question, let's write down the chemical equation to understand what is happening in this reaction. Mixing ammonium nitrate and sodium hydroxide solution gives an aqueous sodium nitrate, ammonia gas, and water. So this question has already been mentioned that the damp universal indicator was held above the mixture, which means that after you have gotten the mixture, this would be your universal indicator and it's held above the mixture like this. So as you can see here, the product here is a gas, which is ammonia, and ammonia gas has an alkaline property. If you refer to the notes that I have uploaded, you will come across this table giving you a list of indicators and what happened when they are placed in an acid or an alkali solution. So as for universal indicator, initially they are green in color, and since ammonia is an alkali, this means that your universal indicator would turn into something like greenish blue, blue or violet. So you can choose any of this color and your answer will be right. So over here, I am just going to say that your green universal indicator turns into blue. Since they're asking you to explain why this happened, it is because an ammonia gas has an alkaline property. So you can say ammonia is being produced. This is the question from May-June 2017, question 3. Describe how you would prepare a pure dry sample of copper nitrate crystals in the laboratory using dilute nitric acid and solid copper carbonate. Include a series of key steps in your answer, and they also want you to include the chemical equation for this reaction. So before we start, let's write down the chemical equation first in order to be clear with this reaction. So this is what your chemical equation would look like. Remember, anytime you have a metal carbonate, your product will always be carbon dioxide with water. Now please don't forget to balance this equation by writing a 2 over here, because you have 2H and 2 nitrate. So this is how you balance it. Now they're asking you to prepare a pure dry sample of copper nitrate, which is this one. Since the question gives you 6 marks, you need to explain how to prepare your copper nitrate first. So your first step would be to add your copper carbonate into your nitric acid until the fizzing stops. When the fizzing stops, this shows that this reaction has completed. So now that your reaction has completed, you can Use the same steps that we discussed before: filter, wash the residue, dry the sample, and crystallize it. So your first step would be to filter out the solution, and when you filter out your solution, you will be able to separate out your copper nitrate. Now that you have removed your copper carbonate after filtering it, the next step would be, as usual, to evaporate your filtrate to remove all the water components. Now after you have evaporated your filter to remove all water, your sample of copper nitrate right now would be very concentrated. So in order to obtain your crystals, you need to let it cool down or dry it in order for it to crystallize. So you can say dry the sample between the filter paper and allow it to crystallize. So if you write this step accordingly, you will be able to get a complete 6 marks. This is the question from February-March 2018, question C. Silver chloride can be made, this is your silver chloride, by reacting aqueous sodium chloride with aqueous silver nitrate. The other product would be sodium nitrate. This is the chemical equation shown. A student attempted to make the maximum amount of sodium nitrate crystals, which are this one. The process involved 3 steps. So the first thing that the student did was add sodium chloride to silver nitrate and stirred. Neither region was in excess. The second step is that the student filtered the mixture. If you filter the mixture, then you can separate your silver chloride and sodium nitrate. The student then washed the residue and added the washings to the filtrate. So this means that your sodium nitrate would fall into here being your filtrate, and the residue here would be your silver chloride. So the student then obtained sodium nitrate crystals from this filtrate. Here you go. Describe what the student observed in step 1. Now step 1 is when you mix 2 aqueous solutions together, and when you mix them together, you manage to get silver chloride. Now silver chloride has a color. If you refer to this table, you would see that chloride ion gives you a white precipitate. So you can say over here that white precipitate is formed. The next question is asking you, why was the residue washed in step 2? So similar with the question that we did before, the reason why we always wash our residue is to ensure that all your filtrate, which is sodium nitrate, passes through your filtrate and it is being collected. Question 3, name the names of 2 processes which occurred in step 3. So step 3, you are obtaining sodium nitrate crystals from the filtrate. So this would be the one where they ask you to lay out the steps in order to obtain a crystal. So some of the steps involved would be evaporation and filtration. So you can use those 2 common processes to answer this type of question. Question 4 and question 5 is not related to this chapter, and we have discussed this sort of question in our previous video. This is the question from May-June 2018, question 6. All sodium salts are soluble in water. All nitrates are soluble in water. Barium carbonate is insoluble in water. Describe how you would make a pure, dry sample of barium carbonate by precipitation. So they want you to include the names of the starting material, a practical detail, meaning how you're going to prepare this salt, and then how you're going to get the precipitate of a pure dry sample out of it, and the chemical equation. So as usual, I'm going to start with the chemical equation first in order for us to understand what is happening in this reaction. They have already mentioned for you over here that you are making a barium carbonate salt, and a barium carbonate salt is insoluble. In order for us to make an insoluble salt, we are going to require 2 soluble salts. Now before we prepare our salt, let's look at the solubility of salt. Since we require a soluble salt which contains barium, I'm going to use barium nitrate, as all nitrates are soluble. So this would be barium nitrate. Barium has a charge of 2, so I'm going to put a bracket 2 here. And already mentioned here, all sodium salts are soluble. As you can see, sodium, potassium, and ammonium are soluble. So I'm going to make sodium carbonate, putting Na over here. Since the carbonate charge is 2, there will be 2 over here. So here you go, this would be your chemical equation, and the other product would be sodium nitrate. Now the next step would be to make sure that this equation is balanced. So we have 2 nitrate and 2 sodium here. Don't forget to put a 2 over here. Now your chemical equation is complete. We can move on to the next step. For the first step, you could simply explain, mix your barium nitrate and sodium carbonate together. Since they are both salt, make sure to dissolve them in water. The next thing that you should do is to filter out your mixture so that you could get your barium carbonate salt in your residue and you get your sodium nitrate in your filtrate. So this would be your filtrate since it is a soluble salt, and this would be your barium carbonate since barium carbonate is an insoluble salt. So that would be your residue. So you should write that as your next step. Filter the barium carbonate off the mixture, that would be your residue. So the next thing to do is to wash your residue. You wash your residue to ensure that your residue is clean and is not contaminated with any sodium nitrate or other particles. Once you have washed your residue, the last step would be to dry it and evaporate it to make sure that there are no water molecules present. So you will be able to obtain 2 marks from your chemical equation, and these 3 steps will give you another 3 marks, a complete of 5 marks. Next question, the nitrates decompose when heated. Write a chemical equation for the decomposition of sodium nitrate. Now when sodium nitrate decomposes, you will get sodium nitrite, which is NaNO2, and oxygen. So the next step would be to balance your equation. Since you have 4 oxygen on your right hand side and there's only 3 over here, you need to balance it by putting 2 on sodium nitrate and 2 on sodium nitrite. The next question, the unbalanced chemical equation for the decomposition of hydrated meaning it has the molecule of water, copper nitrate crystals is shown. Balance the chemical equation for this reaction. So since there are 2 copper here, you're going to put a 2 over here. Your copper is balanced right now. Next, nitrogen. There are 2 over here, meaning 2 nitrogen and a bracket of 2. So meaning 4 nitrogen in total, and I'm going to put 4 over here. We have got a total of 18 oxygen over here. Here we have 2 oxygen plus 8 oxygen plus 2 oxygen, giving you 12 oxygen over here. So if I want to make sure that I have a total of 8 oxygen, it means that I need another 6 oxygen over here. So I am going to put 6 in front of H2O to give me a total of 6 oxygen. And now I have a balanced number of oxygen on both sides, which is 18. The last component that I'm going to check is to see H has an equal number on both sides. Over here you have got 12 hydrogen, and over here you have got 6 hydrogen and 2 in front of here, meaning times 2. So yes, I have 12 hydrogen on both sides. Now this equation is balanced. Next, question 3. When the hydrated copper nitrate crystals are heated, steam is produced. When the steam condenses on a cool surface, it turns into a colorless liquid. So this colorless liquid would be your water. Anhydrous cobalt chloride is used to show the colorless liquid containing water. How does the color of anhydrous cobalt chloride change? So an anhydrous cobalt chloride is initially blue in color and it is used to test the presence of water. So usually when there is water, it would change into pink. So please remember this. Last question, how would the student test to determine if the water produced is pure? Now as we know, the boiling point of water is 100 degrees Celsius. So in order for us to ensure whether this liquid form is pure water or not, what we can do is check to see if the liquid converts into gas at 100 degrees Celsius sharp. This is the question from the specimen paper 2020, question 6. Soluble salts can be made using base, and an acid base is just another word for alkali solutions. Complete this method of preparing dry crystals of the soluble salt. Cobalt 2 chloride, 6 water from the insoluble base, cobalt carbonate. So again, this question, they're asking you to lay out the method for preparing a dry crystal of a soluble salt. And they have already given you the first step here, whereby you are adding cobalt carbonate with hydrochloric acid. This means that you will be getting cobalt chloride with carbon dioxide and water. So just don't forget to balance this equation. Even though the chemical equation is not being asked, just always practice to write down your chemical equation when it comes to finding out your observation or when it comes to preparing a crystal. So your step 2 as usual would be to filter out your residue. Step 2, filter the salt out of the mixture. Step 3 would be as usual, make sure to evaporate it. And while you evaporate it is to make sure that you remove all the water particles. And your final step would be to allow it to cool down or crystallize in order to obtain our dry crystals. So as you can see, this type of question, the pattern is repeating for this chapter. So please remember the steps or the layout. Prepare dry crystals of soluble and insoluble salts. This is the question from May-June 2016, question 4. Describe a test for chlorine. Now, if you refer to the notes, I have uploaded the test for gases, and as for chlorine, you need to use a damp litmus paper, and what happens is that it will bleach your litmus paper. So damp litmus paper result bleaches. F is electrolysis, so I'm gonna skip this. And same goes to G. This is not related to our chapter, so I'm gonna skip this question as well.